Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today live, and we have got a most excellent program for you today because we have a very special guest that we'll be bringing on in just a second. I'd like to take a second and give a shout out to some of you guys who've already tuned in. Rob, welcome. King, Ohio Tech Teen, it's always good to have you here. We've got Sons, we've got Reagan, we've got Victor, we've got quite a crowd coming in, so really want to welcome you guys. I will be watching the chat today to see if you have any questions. I've taken your questions from the earlier video this week and the questions that you've emailed me. I've got an initial list of questions, but I will be watching the chat room here on YouTube. Also, you guys that are Patreons, you can go over to the Discord server, and I'll especially be watching the Discord server for the channel questions for Jetson Hacks. So yes, we have today as a special guest the man, the legend, Mr. Jim from Jetson Hacks. Jim, welcome. How are you doing today?
I'm doing well. How about yourself?
I'm doing great. It is such a privilege to have you on this program because I know that my channel, your name comes up all the time, and you have got a huge fan base. In fact, some people think that you might be one of the more interesting technology voices on YouTube. So welcome.
Oh, thank you very much. Thanks for having me on. I can't live up to that hype.
Hey, I noticed that you have the fire extinguisher in the background.
Oh,
and,
yes.
Inquiring minds want to know, have you ever actually had to use that fire extinguisher?
So the story of the fire extinguisher, when I was in high school in the taking chemistry classes, I had just completed one of my experiments. And the chemistry teacher comes over with the fire extinguisher, and one of those great big, institutional ones, the 5-gallon ones, and puts it next to my desk. He says, "You're going to need this. You should always, whenever you do an experiment, you need one of these." And it turns out he was not wrong. So that's always been kind of just one of the props of I've never had to use it, and that embarrassing day is going to come when something does catch on fire. I will have no idea how to put it out.
Well, I was always thinking that perhaps that fire extinguisher was over preparing in a electronics lab or a computer science lab, but actually have students that are doing high altitude ballooning, and they had one instrument package that they sent up. It was at 120,000 feet, and then on re-entry the parachute did not deploy, so we had a 2-pound LiPo battery that plunged back to the earth without a parachute. Now that was bad enough, but then they decided, limited funding, see if they could salvage the battery, so they tried to recharge it.
Yeah. That's fire.
I won't say, somewhere between a loud pop and an explosion. Maybe explosion is exaggerating a little bit, but we did have to get out the old fire extinguisher. So yes, even in an electronic lab, maybe a fire extinguisher is good to have. So, well, it's really it's great having you here. Really appreciated the chance to talk to you a little bit in the pre-interview, and I just know people are really fascinated by you, and so I was hoping maybe we could ask a few questions, let people get to know you a little bit more. So, could you tell us a little bit about your childhood? Like, did you get into technology as a young person, or did it come along later? I mean, what things did you do as a kid that maybe led to you becoming successful in technology?
Well, I grew up in a time when we didn't have technology.
Okay.
Now we have zeros and ones. We didn't have ones back then. It was only zeros.
Okay.
But so I grew up in the 70s, and back then it was just a different way of viewing life, in the sense that technology was something that you always worked with. So if you had a car, if you have a TV, if you have a radio, you always had to take them apart and fix them. or else you didn't have a TV, radio, or car. So you had a much better feel for how things work. So that was kind of an introduction to technology. And I think the seminal event for most of the people who lived in Southern California that were, 10 years old is you'd go to Disneyland. And they had, at that time, there were a couple of animatronic types of exhibits. One was Abraham Lincoln.
Yes.
And the other one was the Tiki Room. Mm-hmm. And you could always, in some sense, it was like the old Flintstones cartoons. You could always tell the engineers from the way that they criticized the cars that the Flintstones drove. Right. Well, how do they steer that? How come that back wheel doesn't fall off when they're, pedaling along? But like almost everybody, it was one of those things where you're enchanted by the animatronic. And your immediate question is, so how does that work? And Disney has always been pretty good about kind of behind the scenes, because they had kind of the world of Disney at the time. And Walt Disney would get up and he'd say, well, here's the animatronics. The inside is in the animatronics. And that was even more fascinating than seeing them in the actual show itself, if you're an engineer. Uh-huh. Everybody else would kind of roll their eyes and kind of, what do I care about this?
So it kind of spurred your imagination, seeing the things that Disney was doing, and just sort of kind of like the cutting edge technology at the time spurred your interest in perhaps pursuing something like that.
Right. And my father was an engineer. When he retired, he was the head of the space shuttle.
Oh, wow.
So head mechanical engineer on the space shuttle. The crew compartment, as he, the actual bird, not the parts that blew up.
Right. Right.
So that was always, so it was in the family as far as kind of engineering backgrounds.
Right. Well, did you play around with like building models or working on your car or things like that? I mean, what types of things were you interested in a pre-technology world?
Yeah, so there was, I always had a car to work on. Models were always big. We had our little test store models, mm-hmm. Revel models that kind of the precursors to kind of what the Star Wars kit bashing stuff became, mm-hmm. So everybody would have their kind of, you'd first build a model and then you'd kind of put your imagination, how do I make this fighter airplane into a spacecraft and things like that. So it's all kind of, being from Southern California, you're pretty close to the movie industry. So that's always, even though you're not directly connected to it, there's so much of that influence around here that, kind of the imagination part and playing with things that in ways that they aren't meant to be played with is kind of built into the DNA of this area.
Okay. Well, kind of growing up, playing with things and hands-on and exploring things in that way, did you go to college with the intent of going into technology, or is that something that you discovered as you were in college?
Yeah, so I went into college pre-med. So back then it was pretty much... they kind of collared you. So depending on how good your grades were and kind of what your propensities are, you were kind of herded into certain, your guidance counselor was very important back then. Not so much now, right? But you had a guidance counselor who said, you should do this. So mine counselor was named Mr. Gold, and Mr. Gold says, you'd make an excellent physician. Okay. I said, I'll make an excellent physician. So I went to school to become a physician. So I did pre-med for about 2 years. And then I realized I will not be an excellent physician. I need to find something. I need to find a real job that's at least semi-interesting. Yeah. And at the time, there was traditional engineering and hard sciences, physical sciences. But there was a new thing on campus, which was the computer science building. And there was much secrecy around that and very large, expensive machines. So that was kind of the first, you walk into the machine room for the first time and you go, wow, look at all this. I wonder what this does. And that kind of got the bug going. And that was kind of at the time when personal computers were first starting to hit the market. So it was not accessible to the masses yet. So it was kind of, in some sense, it was like a temple of computer science versus, like today where you can almost pick it up on any corner.
So was your very first program, was it at a terminal or was it at punch cards?
Oh, punch cards.
All right. Yeah.
That's like people ask me today, so how do you get started programming? Well, first we'll need a bunch of punch cards. And, so for people who don't know, so punch cards, you would basically sit down at what looked like a typewriter. You'd punch little holes in the card that the computers could read. So you'd have literally thousands of these cards that you would put into a card reader, punch card reader, and the computer would do that, run your program, and then stop. So you put probably 100 hours into running, 500 lines of code, and because it was so expensive to run the computers back then, and you were charged by the amount of CPU time that was being used, that your only goal was to not spend any money. So you'd spend 100 hours, just typing in these programs on these cards, and then you'd run it would literally take less than a second to run the program. And so there's always this feeling of relief. The other thing that an experience that you would remember because you never wanted to go through it again is you'd have all of your cards. So you have 1,000 of these cards that are all in a box. You're carrying them over to the machine, and you know what happens. They just kind of fall on the floor. So they aren't numbered in any meaningful manner. Right. So it's not like you can reassemble them. So it's like, okay, it's just bound to start typing another 1,000 cards up.
Oh yeah, I can remember kind of same era, and I can't remember, but access to the actual CPU was something like $1,000 an hour, and you're right, it just took a few seconds to run the program, but when you signed up for the course, you were allocated some number of seconds for the semester, and the challenge was to get educated without going broke. So I think you were not just motivated by getting a good grade, you were motivated by not having to pay for that CPU time in the class.
And the amazing part is how that was a long, long time ago when computing was so expensive that it's not something you could imagine even doing personally. But that mindset of everything has to be so fast that you're not willing to go to a higher level language, for example. So, I can't do that because it's too slow. I don't understand what too slow means when you're 10 orders of magnitude faster than it was when, back in the day, as it were.
So do you think guys from that era still have in their DNA the drive to write efficient code, maybe more than the new guys do?
I don't think so. I think what happens is it's just built into, they don't make the same inefficiency mistakes, right? Okay. So you just say, well, I can't do that because you know it's wrong. Like it totally amazes me that people haven't always put automatic garbage collection into hardware because, well, it's not flexible enough. It's not fast enough. You kind of go, really? Right. You look at the number one issue across the world in computing, and it's automatic garbage collection, memory allocation errors and stuff like that. Okay.
Yeah. Hey, well, so you started your first program on a punch card, and now you're working on CUDAs and parallel processing and artificial intelligence and all that sort of stuff. Maybe you could fill in the gaps a little bit. Tell us a little bit about your career path from starting out on punch cards to maybe in your career some of the interesting things you've been able to work on, and maybe a little bit about what you're working on now for a living, sort of outside your Jetson Hacks endeavor.
Right. So when I came out of college, I worked on a company that basically a hardware company that made a PDP-11 clone, which was a 16-bit, what we would call a microcomputer, not as powerful as an Arduino, but at the time it was a monster. So we did the standard computer science things of writing assemblers and interpreters and compilers, systems level stuff. I didn't work on the OS as much as most of the other folks. I was a language tools person. And then I went to a quick in-circuit emulator things where we emulated things like the Z80 and 8088 at the time. And then it was off into kind of consulting land where I worked in the oil industry and a little bit in the movie industry. A wide variety of, I'm a generalist, so I want to see a whole lot of different types of environments to work in. So large companies, small companies. I've had several startups that I've gone through. In the last 15 years, let's say, I started working kind of to come back to the Disney thing. I worked for a company that was founded by ex-Disney Imagineers. So they were head of Disney Imagineering, and they left and started up another company. And kind of their tenet was that they would provide Disney Imagineering for everybody else. So that was an intersection of mechanical stuff, machining, electronics, software, and everything was pretty much oriented towards here's a 10-year, here's the vision of your products in a 10-year time span. For 10 years from now, here's what your product's going to look like. And that was, top, I wouldn't even say Fortune 100, it's probably Fortune 50 types of companies. So it's kind of, here's what the future will look like for you. And out of that, we spun out a geospatial analysis company that we mostly dealt with the military. So that was, it's eye-opening to deal with when you think you've worked in a big company, and I have worked in large companies before. When you go to work for, a entity that has millions of people in it, mm-hmm. You kind of go, okay, so I didn't understand what scale really means. You go, oh, so that's what scale is.
Okay. Well, are you still living in the Southern California area?
Yeah, I live in Pasadena, so I'm up the street from Caltech and down the street from JPL.
Oh, okay.
So a lot of the folks in this neighborhood work at those places. So that was the other thing, kind of working. I think the most interesting thing I learned was you need to always work in places where the people are smarter than you are. Okay. So don't be the smartest person in the room in your career, or else you'll never learn anything.
Right. Well, that's, I think, one of the characteristics of really intelligent and really successful people is they want to surround themselves with people that are smarter than they are. Someone told me once that like A students will hire A students and B students will hire C students. And I think to be in an environment where you're constantly challenged by the people around you, that's one of the best jobs that you can have. It keeps things very exciting.
Yeah, well, it's a variety of things. Part of it is you need to be exposed to a whole bunch of things, especially in technology, where you have to be able to draw from a wide variety of things. One of the people that I enjoyed being around was Alan Kay. And it's both exhilarating and exhausting at the same time to be around people like that. So he was one of those guys that he had read his entire public library, local library, by when he was 5.
Oh, wow.
So he has like this encyclopedic knowledge, and the ideas that are based on that. So for me, I'm very much, can you just like give me one little bit to work on so I can kind of go vertical with that? No, you just get it's like drinking from a fire hose.
Oh, wow.
Well, the ideas. But unless you're surrounded by people like that, hiring is such a weird thing because you don't really know who you're hiring until you've worked with them. So a lot of people say, well, A people hire A people. Yeah, kind of, sort of, but you don't really know until you worked with them.
Right.
A lot of people hire people that their resume looks good, but that doesn't tell you who they are, or whether they know anything. Are they the bottom rung of, like somewhere like Harvard or whatever, or are they the top rung of, a UCLA? So you can never really tell who. Are they a big fish in a little pond? Are they a little fish in a big pond? That kind of thing. So I've always found that interesting in working with people.
I agree. I mean, in my experience in the national laboratories, I'd kind of gotten to the executive position, so had a lot of people that worked for me. And one of the things I found is I never found anyone there that wasn't smart enough to be successful, that it just seemed like besides being smart and a good resume, there was just this social dynamic. And it seemed like that people that failed usually failed for social reasons more than technical reasons. And that's a hard thing to really perceive or discern in a 30-minute or one-day job interview.
Oh yeah. Well, and that's it. One of the reasons that they fail is that I found, especially when they're younger, is they think they're the smartest person in the room.
Right.
And you go, okay, you're about to get your butt kicked, but you don't even know it's being kicked. So you're not even smart enough to realize that.
Yeah, I saw that as a big one. Another big one that I saw was not being respectful to the support staff who were possibly less educated. You would be surprised that, when people are offended in the workplace, how they can kind of come back at the absolute worst time and cause a problem for you. So I saw some of the more PhD, kind of like the elite PhDs end up, I don't want to use the word sabotage, but get sabotaged by a person back in the fabrication facility or someone that they had offended at some point. So I think respecting everyone around you is like a really, really good career choice.
Yeah, well, revenge is a dish best served cold. But the thing that you don't really realize until you've worked up in Silicon Valley or somewhere like that is you'll meet a lot of people with what we now know is kind of autism.
Yes.
And you kind of, unless you walk into that knowing they aren't being rude, they're
Right.
just, they don't recognize. But that's a hard assessment to make,
Right.
each time through, because it's a individual thing you have to talk about.
Yeah, it seems like the bigger that math analytic part of the brain is, it seems like that tends to then squeeze out certain other life skills. And so when you work in the really very high-end, high-tech world, you definitely run into some really unique personalities.
Yeah, and you just have to kind of, and it's hard to do at the time, you just have to kind of celebrate them.
Right.
Well, that's a really interesting person.
Right. Right.
Yeah,
well, it sounds like, Jim, that you've just had a really interesting career. It sounds like you've never gotten stuck in a rut, that you've had the chance to move over your career into a lot of different exciting projects to work on. But how did you just one day decide, hey, I think I'm going to sit down and I'm going to make YouTube videos? So how did that come about?
So at the last company I had founded, I realized after talking to the marketing people that I didn't have a real good grasp on how YouTube and social media really work, kind of the mechanics of it. So engineer, right? I'm interested in mechanics. And kind of what the idea was is I was interested in what it would take to put together a video. You know, how much work is that really? How long does it take to have 100 views of it, let's say? For subscribers on a channel, how long does it take to get 10 subscribers or 100 subscribers? If I put out 5 videos, you know, how long does it take to get 1,000 views? Being as kind of my background is software engineering, so I understand network effects. I mean, it's just you draw the graph and that's what it is. But it's a different thing with kind of boots on the ground where you say, oh, so this is what happens when I put out a good video. Here's what happens when I put out a bad video. And as everybody knows, or maybe you don't know, the first videos are always horrible. You make up the YouTube videos, and you look at them. If you go back, even 3 months later, you just go, it's just cringeworthy.
Yeah. I started out with a webcam and screen capture software, and for whatever reason, using a webcam with screen capture, there was like a 2-second delay between my voice and my mouth moving, and so I look back at those, and like you say, I'm just really embarrassed by the production quality of the early videos. But I think one of the things that really distinguishes the videos that you're making, I mean, they really are like broadcast quality. I mean, they're just really, I mean, it's this unique combination between you are genuinely a subject matter expert. I mean, you really know the subject area that you're talking about, and then you combine that with just this really exceptional production quality of your video. So we see that you've spent your life developing that subject matter expertise. Did you come into this with the expertise on the kind of production quality? Had you worked on videos before, or did you just sort of learn as you go to get to the point that you are now?
So I had worked a little bit in the movie industry, and all the things that they talked about, all of a sudden they suddenly became real. So, that's what they were talking about when the lighting's bad, and here's why they have the 85 lights on them, and here's why they have this type of microphone, and here's why so that all the little things that add up for production quality. So there's kind of the video production, and then there's also kind of the storytelling, which is much more important. The scripts, the kind of the little tags, the characters, the shark, or the fire extinguisher, or whatever, the things that get people kind of involved. And it kind of also tied together my interest in music. So I've been playing music or guitar since I was a kid. So that was kind of, I knew how to do the music part of it pretty easily. So I understood sound recording probably better than most people because I'd recorded stuff.
So your background, your soundtracks in the background, is that you playing, or is that actually your music in the background?
Yeah, it's just me and some friends jamming on a Saturday usually. So I have hundreds of hours of those. My friends, they do like professional stuff, but we've been playing together since I was in college. So
okay. Well, the neat thing about your soundtrack is most people that use a soundtrack make it too loud where it becomes a distraction from trying to focus, but you've got just that perfect volume where it's kind of just like creating this learning zone. It's like enhancing the learning experience and not distracting from it. So I do enjoy the soundtracks on your videos.
Yeah, so for you tech freaks out there, you want to do your audio at like from -6 dB to -12, and then you put your music probably -24 dB, and that kind of gives you kind of your baseline.
Okay.
That's one of those things that it takes you, you have to watch like 25 videos before you find someone who who actually knows. Do this.
Hey, I need to give a shout out to the Ninja who just gave us a super chat. So very much appreciate that. Appreciate you guys who are helping out over in the chat room. But let's see, Jim, can you talk a little bit about what your setup is? Certainly you're achieving broadcast quality videos, but like, could you talk a little bit about the cameras you use? Like, do you like your editing software, things like that? I mean, how did you? What is the equipment that's back there that's helping enable such high quality content that you're producing?
It's pretty low level stuff as far as quality goes. I use a couple of Canon Rebel cameras. The older one is a T5i and the newer one's a T7i.
Okay.
And then for the audio, it's basically this mic. This is a SM57, which is kind of if you don't have the windscreen on, you'd recognize it immediately as a stage mic. So everybody does, just from one of the bands I was in.
Okay.
It's probably 30 years old. The only really interesting thing I think that's out of the ordinary that people ask about is to record the Jetson screencasts. I think it's an Elgato HD Plus. So it's just basically HDMI to USB converter. And then everything, I started out with iMovies, so the first probably 100 videos were just very simple iMovie on a Mac. And then I have switched over to Final Cut Pro 10.
Okay.
So it's, as far as esoteric or anything, it's not particularly. And it's just the lights that I use are basically, a junker $100, 3 lights that I bought, off-brand Amazon thing. But the lights are like a big deal.
Yeah, and it seems like that there are a lot of things that go into the production quality of a video that are way more important than how much money that you spent. And it seems like that with a fairly low-cost camera, you can get the video quality you want. It's like, you don't need to go out and spend $2,000 for a camera. For me, the thing I struggled with the most was audio quality. That getting a reasonable audio for me was a lot harder than the video. But it sounds like you had music background, so you probably came to the table with a lot more audio experience than I did.
Yeah, so I think that has gotten a lot easier over the last year. Shure, who makes this microphone, they just came out with a USB version of their SM7B, their broadcast mic that you see on virtually all the podcasts. The issue with their high-end mic, the 7B, is that you have to have like a recording studio to be able to get it into your computer.
Right. So
you probably need an extra, it's a $400 mic, and then you need another $1,500 to get the good sound into your computer. They came out with a $250. It's not a direct copy of it, but it's close enough for rock and roll. Mm-hmm. But it has a USB output.
Okay.
As well as XLR. So if you're doing like a podcast where you're doing a bunch of folks, you need XLR. But you can also do USB, just so you're done, basically. So for $250, you get a solution that you couldn't have gotten for less than, $1,000.
Yeah.
A couple of years ago.
It's probably some low number of hundreds of dollars that a person could have a decent content if they really focus on the things that you were talking about earlier, the planning, the scripting, the, sort of having, the overall program thought out and planned and laid out.
Well, I think so this is non-intuitive. You spend the most time on your audio. So that should be, if you're doing these types of broadcasts, because that's what people are listening to. They'll put up with bad video, but they won't put up with bad audio. Right. So spend 50% of your time getting your audio right and your budget. And it turns out that almost all of the cameras now, if you're going to a real camera, even entry level stuff's acceptable. But so it's the camera, but I would spend some time on lights. So lights are like, it's also, that part is intuitive because that's what the camera is capturing, is the lighting, of the image. Yeah,
so the lighting and the microphone, I agree. Those are like kind of like some of the biggest bang for your buck is the lighting and the microphone. I will say though, I struggled with the screen capture that you were talking about, and because I do live recording, so I don't so much make shots and edit as I just teach a lesson and record it, or like we're doing today, live streaming. And I tried a number of different screen capture boards, and they would have a tendency at the worst possible time to lock up on me or to glitch out. And so I finally had to get like the Magwell HDMI to, and those things are fairly expensive, like maybe $300. But it just it was sort of the frustration I was having of that one component causing me to have to stop and redo things, and so that's one thing I put a little money into.
Yeah, live streaming is a different gig. Typically, what people would do is you would use something like a Blackmagic Design ATM Mini or Mini Pro.
Right.
And that gives you enough flexibility, inputs and outputs, and it's hardware, so you don't have to, the whole thing kind of disappears. But it's, it's $400, $500.
All right. Well, that's certainly, we all tip our hat to you and where you have ended up. It sounds like that you kind of started the channel more as a thought experiment or as a learning experience for you. You weren't thinking, I'm going to go out and, equip the world to use artificial intelligence. But that's kind of like you've really opened artificial intelligence up to a lot of people that might never have otherwise used it. I think I actually was first introduced to the Jetson line through one of your videos. I was probably watching an Arduino video, and your video came up as a suggested video. And I'd always just viewed artificial intelligence as being like way beyond what I could do. I sort of knew a little bit of Python, but I ended up watching your video, and I think it was the one where you were just launching the camera, and it was like, if I remember right, it was like OpenCV, and you were like grabbing a frame and showing a frame, and it's like, wow, this is kind of doable stuff.
Yeah, it turns out you don't need punch cards anymore.
Right.
So a lot of things that were unreachable even, 5 years ago are, they're within your tool bag now. So one of the things we talked about kind of earlier was tools as far as what computing's about and knowing the full stack. And that's kind of what AI is. AI is a difficult term for me because it's such a wide thing. It's kind of like robots, where you think about, so what's a robot? Well, is it a Roomba? Is it one of those big arms on a manufacturing plant that's, welding cars together, things like that. So AI is this very broad term, but you have to kind of view it as it's part of your toolkit. So it's like a hammer, or it's like a screwdriver or something, where you would actually use it in a given circumstance. And video is kind of lends itself towards that, where you can take an image and then analyze what's in the image.
Yeah, right? and that's really kind of what hooked me. Just, like, to me, artificial intelligence, again, it's like neural networks and machine learning and all this different stuff that just was like a foreign language to me. But what I recognized watching your video was you were grabbing a frame and showing a frame in like 2 lines of Python code, and you're like operating at 20 frames a second or 30 frames a second. And between that grab a frame and show a frame, it's like there's with 128 cores there's like an infinite amount of time between grab a frame and show a frame to just do all of this magic. And that sort of combined with the fact that the Jetson Nano has access to those GPIO pins, it's like just this entire universe of possibility was opened up, that I could be sitting between grabbing a frame and showing a frame, and I could be working with GPIO pins, and it was like, wow, there is no limit to the neat things that we could do with something like this.
Yeah, and look, in comparison to something like a PC or something like that, or a notebook or a laptop or whatever, you get a much more, I'll say, laboratory feel. So you feel like it's much more accessible, just because you can see the beady little eyes of the chips as they stare up at you, you know, and you know that you can actually hook GPIO stuff on there. Yeah, there's no better thing than when you turn the LED on for the first time from the GPIO pins, or hit the button and something happens.
Yeah.
Yeah, you know, or to be able to program a game controller, or, you know, things of that nature, where you actually, oh, I got an image. Oh, it has a thumbs up in it, so let's, you know, turn a light on. Oh, okay.
Yeah.
But you don't get that feeling when you use a notebook or, you know, a desktop computer.
Yeah, and I believe you did some videos on connecting servos to the GPIO pins, and so you're sort of, you know, able to process an image and then do something with servos, which I thought that was a really neat lesson, and kind of opens up a lot of possibilities for people.
Yeah, I think that's one of the differences kind of between our channels is, so you're very hands-on as far as, you know, here's how I go about doing this, here's how, you know, let's learn it together. I'm very much of, you need to put your own imagination on what you would actually do with this. Mm-hmm. This is more like nuts and bolts of, I'm a developer that already knows all this, but I don't know how to do it on this platform. Mm-hmm. You know, so I always view kind of my channel as, these are notes to myself that if I have to go back and do this again, here's how I do it.
Mm-hmm. Well, it's good, and it's certainly very wonderful for those of us who, you know, maybe are smart people or educated people, but not computer scientists. You know, the whole AI thing is kind of a hard thing to break into. It just seems like there's a bunch of people speaking their own language, talking to each other, and it's very hard to just come into it, you know, willing to work, willing to learn, but it's hard to find that foothold where you can get into it. And like I say, your videos were what made it possible for me, because, like, okay, I know a little Python, and I could look at your scripts and I could see what you were doing. I mean, it's much better than what I would know how to do, but I could at least understand what you were doing, and then I could go away and I could say, okay, you know, this is my idea, this is what I think I'm going to do. And so I think your channel is very very powerful and beneficial in that it can enable people who maybe are smart and hardworking but don't know the area. It's a way for them to kind of break into it.
Yes. So let me add one more thing there. I've started working with NVIDIA. We just put out a set, it's about 4 hours worth of videos on Jetson AI fundamentals. So that's kind of one of the, you know, we take you through kind of getting started from, you know, how do you burn the SD card to get started on your Nano, all the way up through, so here's how you do object segmentation, and here's how you know, Dusty goes through. I think he had like 2 hours of going through kind of fundamental AI on the Jetson. So I think it's a lot, it's very accessible. There's no, you don't have to have it's very much black box. Very much a black box kind of feeling to it. So you don't have to have intimate knowledge of, you know, exactly what you're doing, but you get a feel for what it is. And mine was on, I think I did the JetBot.
Well, I think that it
There he
also
is.
oh, okay, there. Yeah, look at that. Yeah, I've got a JetBot still in the box. I have not managed to get the thing out and put together yet. But that's one of the things I'd like to like to kind of get into. One of the challenges I find a little bit with the trying to create educational material around the NVIDIA products is that things are changing so quickly that you've got Jetbot or you've got Jetpack 4.2. You make a series of lessons, and then things are different in Jetpack 4.3, and it's not just the jetpacks, it's OpenCV changed and PyTorch changed, and there's just this massive number of libraries that are all changing, and then things that worked in the configuration you have don't work on the next configuration. So it seems like it's challenging to create educational material when a field is changing as quickly as this is.
Yeah, I think one of the things they're doing to address that is to start containerizing all their stuff. So that's kind of Docker. Now instead of doing these monolithic releases for the OS, you'll have the OS changing underneath it, but the actual Docker containers won't change very much. So it becomes a much easier process as we go along. So that's part of Dusty's Jetson inference type of things. So that should become easier over time. That's one of the kind of the issues that they've identified at NVIDIA, and they're trying to address that because they have the educational resources that they provide are very extensive, university and high school level, in addition to, that's one of the kind of the drawbacks of my channel, right? So they were notes to me from 2 or 3 years ago, and people say, well, why haven't you updated this? That's not the intent of the channel. The intent of the channel was to get you asking the right question. So that's one of the big things today is you have to the first part of any of these problem solving things is to understand what the name of the thing that you're trying to solve. Or get you pointed in the right direction. So that's kind of what a lot of my scripts do is here's the process that you had to go through, and at least you know the names, but it's not meant as a turnkey solution 5 years from now.
Yeah. Well, tell us a little bit about where you see your channel going in let's say in the next year. What are some projects or some videos that you might be mulling over in your head, and some stuff that we might see coming down the pike as we're going into the future?
So I think there's a couple of interesting things. I'm going to probably do a little bit of a pivot away from the lower end stuff and go into a more technical world. So here's the idea is I'd like to run a series on what I'm calling the JetsonHacks development series. And basically that is, so you want to develop on the Jetson, here's how you set it up. Here's let's develop a project. So that might be something like install Visual Code Studio. We're going to do an RTSP, kind of an IP camera that's running on a Jetson Nano 2GB. So for $100, you can do this IP camera. So that's kind of when you buy an IP camera from the store, here's what you get. Here's what's really inside it when you stop to look at it. And here's how you do H.264 encoding or, all the kind of the technical stuff. And there's enough of those types of simple projects that to get started to build something really interesting that'll probably happen over the next I'm thinking the next 6 months is probably well taken care of with that type of stuff.
Yeah, well, that sounds really exciting because I think it's one of the best ways to learn is when you're doing something interesting as opposed to just writing code. And that's kind of what I find with students as I teach, that if it's a project, it's way, way more interesting than some of these online code academies where you're just writing code for the sake of writing code. But if you've got a little kit in front of you and all of a sudden you are building a circuit and lights are blinking or motors are running or cameras are working, that's really way more exciting than just kind of raw coding.
Yeah, and I would kind of the first thing I would say to anybody who is going through kind of the Jetson stuff is and you're interested in robotics at all, is to do the JetBot project, build it from scratch if you can, just so that you understand kind of the principles behind the mechanics involved. But it's, even as someone who's jaded like me, it's pretty magical when you see the thing work. You just go, how would that ever work? And then all of a sudden it starts working.
Right.
It's very, very, very similar to telecommunications. You know, you always wonder, well, how does a modem work? How does the Ethernet work? And if it doesn't work, then you're convinced it will never work. Right. And if it does work, then it's absolutely amazing. You know, it's like a printer, right? Printers are always, it's absolutely amazing when you see a printer work, because you know how much it had to go through to get it to work, right?
Yeah. Well, that's like one of the number one questions I get from my live students or my YouTube students is, mine's not working, like it's not working, like something's wrong with it. And I ask, well, what's it doing? And the right answer is it's doing exactly what you tell it to, right? So it's like, I think for new people, you've got to get past this barrier that there's something wrong with it. You know, it's just like it's something that you're doing and you've got to get to the bottom of it. And I think, learning how to troubleshoot and debug is a really, really important skill.
I would say an equal skill to that is to learn to ask for help correctly.
Right.
Because you end up with a lot of folks saying, so this is every video I've ever done. I did exactly as you said, and it doesn't work.
Right.
What's wrong? Can you help me? Okay, I can help you. You should learn to report bugs correctly.
Right. If you are doing exactly what I did, you would be getting exactly the result I got. Is kind of,
well, and to be fair, there's certainly a chance for errors in the stuff that I do. But at the same time, the stories are almost endless. Right. But, I'm having trouble with your program. Okay, so what's wrong? This, and this. Okay. So that doesn't make any sense to me. And as a programmer, and I've dealt with professional programmers for a very long time, your immediate thought is always there's always this one little routine buried so deep in it that it has to be that one, right? So there's always something wrong. But then when you start asking questions about it, you kind of go, what machine are you using? Well, I'm on my desktop. Okay, well, that's exactly unlike what this is for, right? But you end up with, so at the very least, tell us what Jetpack version you're using, or, right, which Jetson you're using would be useful. Yeah. It'd be nice to have kind of like at least a semblance of the error message that you're receiving.
Right. Yeah, so I think you're right. Asking the question right is good because it also increases the chance that you'll get help. That, if you tell a little bit about what you've tried, indicate that you've made an investment in the problem before you just run out and ask the question. Because I think that if a person has made a significant investment in trying to make something work, then you're a little bit more inclined to try to help. Let's see, Jim, let me ask another question. That there's a lot of young people on my channel and a lot of people that are, there's some really amazing high schoolers out there that are doing some really incredible things, and they're wanting to be successful in high technology. They're wanting to pursue a high technology career. What advice would you give to someone in high school that really would like to, have a great career in technology?
The first thing I would say is you need to have a broad education rather than a vertical education. And by that, I mean you have to have kind of a basic understanding of a lot of the different technologies that make up, let's take computers, for example, just to kind of narrow it down. The actual stack that runs computer software, hardware, is a very broad thing that you need to be aware of. So you need to understand computer architectures. You need to understand computer engineering. You need to understand kind of software engineering. It's okay once that you have kind of this broad knowledge of the technology, to specialize from there. But it's also important that you understand, and so this isn't immediately apparent to most people, but hardware is just software, and software, runs on hardware. There's always kind of this delineation, and we usually call delineation firmware. But in some sense, software is, or hardware is sand that has been formed into, to perform software. It's for example, in computer, if you're going to be a computer science person, you should know how to do on the software side, how to write an assembler. That's one of the things that a lot of people skip over nowadays. But that means that you won't be able to talk to hardware efficiently. That's the same thing as you see it sometimes when people talk about writing drivers. In some sense, that's a assembler type of thing. So you should understand assemblers, compilers, interpreters, translators. You should understand algorithms. You should understand a whole, it's too long to list here, but there's literally 2 or 3 years of stuff that you need to kind of broadly learn.
Yeah, I think you're really right. And there also seems to be kind of like an intangible associated with this, that things are changing so quickly that you need to have this skill of being nimble, and you need to have this skill of knowing how to learn, and you need to have this skill of knowing how to break things down analytically and troubleshoot things. That kind of the idea of maybe early in my career that you would go to work for a company and you would work in a highly specialized area that you're an expert, and then that's how you would spend your career. It's just, that's not the world we live in anymore. It just, things are changing so quickly. It seems like things of knowing the fundamentals and knowing how to be nimble are really important these days.
I would add to that one of the important traits that you need to learn is how to cut through the nonsense that the marketing people come out with. Right. So if you look back here the last 5 years, you would have swore that Hadoop was the most important thing that's ever happened, or blockchain, hash tables.
Right.
That's extremely, we're going to form the entire company around blockchain. Okay. I don't know what that means, because it's just a hash table. That's a stupid idea. But that's the same thing they're doing with machine learning. So you need to put in filters for what technology is versus what marketing technology is.
Yeah. Hey, let me, our time is rapidly coming to an end here, but I've been kind of looking at the chat rooms and taking some of the questions. This one really struck me, and like, what is your opinion right now on quantum computing? Because you kind of spurred it with that delineating the real from the imaginary. Is quantum computing real? I mean, is it really solving problems, or is it always going to be that technology of the future?
That's an interesting question. So some very smart people are working on that, and you can't just summarily dismiss it because there's been too much investment in it. Even if you end up just emulating quantum computers, from what you've learned from it, it's an important thing, because it's kind of the basic idea is, instead of just zeros and ones, you also have kind of this other state. So combining those things, like, I think they call them qubits, right? Is once you have 7 or 8 qubits together and you can do everything at the speed of light, then it becomes a very interesting thing as far as the computing capabilities. But at the same time, you have to think about, have we really exercised traditional computing? And, that's where, realistically, that's where everybody is, right? That's where everybody really works. Mm-hmm. There aren't that many people doing quantum computing.
Okay, well, appreciate your insights on that. And it looks like our time is coming to an end here, and I just want to express my appreciation for you coming on, because really there's just an incredible interest in you and the work that you're doing, and a lot of people just wanted to kind of get to know you a little better, and you've just been very helpful today, a lot of great advice, and so we really appreciate you coming on. Is there any questions that we didn't ask that you think were important, or anything else that you would like to say?
Well, I think we had a pretty good first chat. That's one of the things, people say, so how do I get a career like yours? I would say you need to have a higher bar as to what you want to do in life. Technology is so interesting right now, and there are so many different areas that you generally don't even think about being technology driven. One of the funny things is, like, you don't think of a farm as an interesting place technology wise until you go to one and you see their self-driving tractors and you get their aerial views and you get all this, just flat out technology that is running the farm. So if it's reached out into, that area, then everything else, and most people live in kind of more urban areas, you see the technology all around you. So always ask, how does this thing work?
Yeah. Okay. Yeah, well, Jim, we really appreciate having you on today, and I want to thank all the viewers out there. I'm sorry we couldn't get around to all your questions, but it's just been a real privilege to have you on, and would just like to let you know, Jim, you're always welcome. If you ever have any exciting ideas or anything that you'd like to share with our audience, you're always welcome to come back on.
Well, thanks. I appreciate being on, actually.
Okay. All right. Well, we will talk to you guys later. This is Paul McWhorter from TopTechBoy.com. We've had a very special guest, Jim from JetsonHacks, and we will talk to you guys later.